Hi everyone, today we're talking about the perimeter and the area of a rectangle. Now since this is your very first lesson on area and perimeter, I'm just going to go over some basics to begin with. The first thing is area is what's inside of a 2D object. So it's literally how many squares, like how many 1 by 1 squares fit inside your shape. If you think about tiles on the floor, that would be a great way to look up what area is, a picture of area, or how many square feet of paint you would need to cover something in paint. The area of a rectangle can be written as base times height. It can also be written as length times width. If I were to look at a tile on the floor, and let's say the tile on the floor is 1 foot by 1 foot, my area would be 1 foot squared. You also square the units. When I'm multiplying them together, it becomes 1 foot squared, which is literally a square foot. It's not a length, it's filling in the boxes. So let me give you an example. Let's say this h was 2 and this b here, the base was 4. And I broke this up into 4s. That wasn't really good, so I'm going to erase and try again so it looks more even for you. I'm going to break that up into 4s. And I'm going to break the side into 2s, there would literally be 4 times 2, or 8 1 by 1 squares. That's what it means to have a square area. Now, perimeter is the opposite of that. Perimeter is a length. It's like the fence around something, or if you had a piece of rope and you were going around an object, how much rope would you need? Well, let's talk about that same 1 by 1 block. So let's say these were all 1s. How much rope, or what a frame, how long would my frame be if I was framing a picture that's 1 by 1 by 1? It would have to be 4, because I'm adding up all of those as a length, and it would be 4 feet, not squared. Squared is for area, because it's how many boxes. Perimeter is a length. It's how long around something you have. The perimeter of a rectangle can be simplified as being 2 times the base plus 2 times the height. Now this works out nicely when we're working with just regular rectangles. If we move on to some shapes that are like compound rectangles, or shapes that have more than one, you wouldn't necessarily use a formula. You would just add up all of the outside lengths of whatever shape you were given. Let's go right into an example. Example 1 says find the area and perimeter of this rectangle. Now to get full credit, I know you're going to have area and then equals base times height. You're going to have to show your formula. I know you're going to get points for that. Your base would be 8 and your height would be 3. The arithmetic behind this is not very difficult. 8 times 3, 24. And my units were in yards, so this is going to be yards. And we're literally finding how many squares fit in there, so it's yards squared. Let me break it down for you. So if I break it into 8s, make sure I've counted right, and then this side by 3s, you're literally counting how many squares, how many 1 by 1 squares fit inside the shape, which is 24. Now, finding the perimeter is we're adding up all of the outside lengths. So there'd be 8, 3, and then 8 and 3 again. Your formula is 2 times the base plus 2 times the height. It works nicely here because we're dealing with a regular rectangle. Like I said, if we get into some complex shapes, you won't even bother with the formula. You would just add up all the outside numbers, whatever lengths that you have. But in here we will, because it is simple. 2 times 8 plus 2 times 3. 2 times 8 is going to be 16, plus 2 times 3 is 6. 16 plus 6, 22 yards. We do not square perimeter because all you're finding is the length, or what the fence would be around a rectangle, around the shape. Now I'm going to get into some more complex figures. This figure here is made up of multiple rectangles. So there's going to be a number of ways that you can go about solving this to find the area and perimeter of this shape. One of them would be to draw an auxiliary line. And that's a line, named for a line that you add in sort of a geometry problem that helps you in the problem, but it doesn't really exist in the problem that you were given. So we can add up two separate rectangles, or the alternative would be make this a complete rectangle and then subtract off the blank space. You could do it that way if you'd like. Have two, find the area of the big rectangle and the small, and then subtract off. But in this case, I'm going to show you how to add them together. So I have two rectangles, so I'm going to say the area of the first rectangle, we'll call that one A, plus the skinny bottom one, we'll call that rectangle B. Do you have to show this? No, but it really helps you in organizing. Now A, we're missing our dimensions here, so we've got to come up with our numbers. A, now if I'm looking at my dimensions, I'm looking for this bottom piece here. Well, it's not going to be 40, because 40 is the whole way across. And it's not going to be 24, because 24 is over here. But if I subtract those two, that's what will be left for that base. So 40 take away 24 is going to be 16. So that number goes up here as well, because we'll need that later, 16 feet. So for A, I have base times height, and B is base times height. But I don't want to get them confused, because they're different. So our base is 16 for our first one. Oops, things went a little wild there. Our base is 16 for our first one. And then the height, so we know it's not going to be 32, because 32 is the whole way. But we've already used 12. So then that would make this piece 32 take away 12, which is 20. So this side's going to be 20 feet. Plus, oops, excuse me, times, we haven't done the times part yet, times 20, because that's the height, plus the base and height of the second rectangle, which is on the bottom, which we can easily come up with. The dimensions are 40 by 12. So 40 times 12. So then I have 16 times 12. 16 times 12, which is 320, plus 40 times 12, which is 480. And together, we have an area of 800 feet, and we're literally finding out how many square blocks, so 800 feet squared. Now this is the perfect example of where I said sometimes you have complex shapes and it's not beneficial to use the formula. In fact, if you use the formula, you're going to create yourself more work and maybe get it incorrect, because you'll be adding pieces that actually don't exist in the perimeter. Perimeter must be the outside of your shape. So it's only the numbers that are on the outside that matter. And we can simply just add those up. I would encourage you to go clockwise around the shape to make sure you get everything. So I'm going to start with 32. My perimeter is going to be 32 plus 16. This is how much fence or how much rope I would need around the shape. Plus 20, plus 24, plus 12, plus 40. And now I've made my way back to 32, so I know I don't need to count that again. And then I'll punch all these into my calculator. 32 plus 16, plus 20, plus 24, plus 12, plus 40. I'm getting a perimeter of 144 feet. And it's not squared because it's just a length. It's like the rope that would go around the shape. The last one that we're going to tackle is we're going to find the area of this shaded section of the following figure. Now this one we're going to treat a little bit differently. You could break it into two rectangles and add them together, or you could use the empty space to your advantage, finding the area of the giant rectangle and subtract off the little one. That's the way we're going to choose to do this problem. So it's going to be the area of the big rectangle, take away the little one. You may choose to do the work in two separate places and then do your subtraction later. That's fine with me. Just as long as you show all your work, it's okay if it's in like two different places and you do the subtraction later. Base times height of the giant rectangle is going to be 30 by 30, minus the little one is 18 by 10. I think this one's pretty easy to go about solving. 30 times 30, 900. And then we're going to subtract 18 times 10, which is 180. 900 take away 180. 720 inches. And area is we're literally finding the blocks, the 1 by 1 blocks. So it's inches squared.